Because what I want to show you now, I want to introduce you have reflect over the y, you have vertical stretches compressions, right? But you also have the horizontal stretches and compressions, and that'll be multiplying just to the x. Okay? So I want to add in reflect over the x, and this one, or no, reflect over the y, sorry, reflect over the y. And then this b here would be the horizontal stretch or compression. Okay. Now this one's a little bit trickier because for my horizontal stretch and compressions, you have to have it as a fraction. You have to have it 1 over your b. And your b would be what you're stretching or compressing by. So if I look at this example, I can see that I'm multiplying the x by a 2. So I know that's horizontal, but I have to have it in the horizontal form as 1 over some number, right? So what is that number? 1 divided by what gave me 2 to put in there. That's what you kind of have to use your brain for. So it's in this form, 1 over b. So 1 over what number equals 2? Because that's what I have there. Very good, 1/2. Yep. So 1 over 1/2 is 2. So really, this is a horizontal compression of 1/2. Okay? So basically what you're doing is, if you just think it's backwards, just like left and right is backwards, adding is left, subtraction is right. If you just take this and flip it, that's what it is. So 2 over 1 becomes 1/2, so it's a compression of 1/2. If I had something like a 1/3 x, right, and I flip it 3 over 1, that'd be a stretch of 3. And because that's my b would be 3 there, if I had a 1/3, okay? So horizontal compressions, they do change your graph a little bit. You just can't assume that your vertex is right 1. Okay, your vertex just isn't going to be right 1 here because a horizontal stretch compression this way will change your vertex. Vertical stretches and compressions didn't, but horizontal will. So it's kind of hard to mental math graph these. You really do need a table to graph these ones. And I'm going to show you how your calculator will also shade for you. It's kind of cool. So if I go into my calculator, go y equals, okay, clear that out. I need to find some points. Now, if you go all the way over to the left, see this line right here? If you go all the way over to the left until it's blinking and push enter twice, you'll get this, and that's the greater than symbol. Okay? Then I can put in my absolute value, math, num, abs, 2x minus 1, and then graph it, and it'll shade the correct portion for me. And greater than means shade above, so really what happened is my vertex here, and I shaded above my vertex. That puts me inside the absolute value. Okay. But then I'll need some points to graph. So second table, find some symmetry. And what you notice is that you don't have your vertex here because your vertex is going to be 1/2 because of my horizontal compression of 1/2. So my vertex is actually going to land right here between this 1 and 1. Okay, so I'll kind of guess where my vertex is. So, but these points would be good to graph. So -2, 5, -1, 3, 0, 1. Okay, so my vertex is going to be right here, 1/2 probably. And it'll look something like that. Solid line, right, because it's greater than or equal to. So you have to remember dashed or solid lines on these. This one's going to be solid. And greater than, I would be inside my absolute value. Let's try another one. If you don't have y by itself, you have to get y by itself. So on the next one, my first step would be to get y by itself, add the 7 over. Okay. So now I can say, yep, left 2, up 7. And since there was no horizontal stretch compression, right? There's no horizontal thing going on here. I do know my vertex is left to up 7. Okay, so let's find some points to graph with that. And again, it's a less than, so less than if you go back over, way over to the left and push enter again, that's the symbol for less than, is when the bottom half is full. And then absolute value, what do I want? X plus 2, and then plus 7. Whoops, I have 2 pluses. Graph, okay? And that would be less than, below the absolute value. And you can see that. Find some points, so second graph. Where's some symmetry here? There's some symmetry. So negative 5, 10, negative 4, 9, negative 3, 8, negative 2, 7, negative 1, 8, 0, 9. And this is going to be solid again and shade below. Okay. We'll do one more together. Again, I would have to get y by itself, so this one would be subtracting 5. So I have this. And this is another one of those crazy horizontal ones because I have to think 1 over what number gave me 3? It'd be 1/3. 1/3. So really, it's a horizontal compression of 1/3 and then down 5. Okay, but remember the horizontal is going to change your vertex a little bit, so be careful. So where's my graphing calculator here? So y equals less than, I'm going to keep that, absolute value 3x, close my parenthesis, subtract 5, graph. And there it is, but I do remember on this one it has to be a dashed line, right? It's got to be dashed. So find some points. Second, whoops. So what are some good points? Find symmetry. There's some good symmetry. Negative 3, 4, negative 1, negative 2, 0, negative 5, 1, negative 2, 3, 4. And it's going to be dashed and less than.